So from Boltzmann's distribution, Einstein actually said prediction that the transition between two energy states will happen like this. Absorption will result in electrons going up a state. Emission will require things to go down. So from here, he said that there will be 3 different processes. He said that there would be one process that's called spontaneous emission. There would be a stimulated absorption. And he came up with this new process that he called stimulated emission. And there's a lot of math that he did, which you guys may or may not be interested in, but I have done it. And you know what that math leads us back to? Guess what? Yes. The spectral equation that we wrote in the first page, it leads us directly back to it. And I have proof. You guys can see it. Do you see that equation right there? I'll pass this around. That equation with a few different constants. Can you pass this around and show the next person? Okay, so now let's talk about these 3 things, guys. And this is called, now ready for it? Have you all have stars in them? Okay, this is called Einstein's theory of light-matter interaction. Theory of light-matter interaction. So I'm going to draw 1, 2, 3. So the first one is spontaneous emission. Number 1, spontaneous emission. Number 2, simulated absorption. And number 3, simulated emission. So each will be divided into 2 parts. I'm going to do a before and I'm going to do an after. That one, before and after. And that one, before and after. So if I have a before emission, this should be here. And it wants to go, emission will require a photon to be emitted and for me to have this fall down. So this will go down and I will have a photon that's emitted for emission. For absorption, guys, do we all understand how I did that, right? For emission, you should have 1 electron in the excited state it will go down and a photon will be emitted.
Yeah.
Corresponding to E2 minus E1 equals HF. Okay, for an absorption, I will have my electron in the ground state. The correct photon will come in. Again, corresponding to E2 minus E1 equals HF. And afterwards, I will have electron jumping up the energy state, going into its excited state. Now, Einstein predicted what we could do is something really cool. He said, if I have this scenario already, something in the excited state, and I now give it a photon, what will happen? I will get 2 photons out, and my electron will come down. So I will get 2 HF. And that is called a simulated emission. And Einstein said, so in 1916, Einstein showed the existence of thermal equilibrium between light and matter by explaining the 3 processes above. And the conditions that he gave us were 1, incident, we must have nearly monochromatic field of frequency. Remember that fancy looking F I drew for you? And irradiance I. And number 2, for your target, must have atoms with energy levels E1 and E2 resonant with incident light. That is, E2 minus E1 must equal HF. Oh, the funny looking at. Then the line shape, the one we were talking about last time, then the line shape function G as a function of that funny looking F that we did last time of the transition with respect to incident frequency F will be given by where this is the funny F0 and this is the G as a function of that. And the atoms themselves must have 2 energy levels each. what colored light? Okay, green. Incident on it. And what we will call another term that I'm going to introduce, population density. Of each atomic energy level. I'm going to call this N1 and N2 corresponding to level 1 and level 2, right? So N1 will have energy E1 and N2 will have energy E2. And all that means is the number of atoms. So number of atoms with energy E1 and number of atoms with energy E2.